All right, hello people watching this video. We are in the second half of 10.2. Looks like this. We're doing the law of sines. Yesterday we talked about how there's sometimes where you have triangles that don't work, where you have no solutions, or you have two solutions. Otherwise, we're just solving using the law of sines. We're going to skip example 4, but we're going to go and do example 5. Okay, so we'll do one of those, but not both of them. We'll just do example 5. Here we go. So, and then we have area of a triangle that we've got to talk about, and that's example 6 and 7 and all that good stuff, and then we're good to go, okay? So 3 examples left, starting with 5. A plane is flying in a straight line parallel to the ground, so they have like kind of this horizontal line coming off of him that passes directly over point A, and then later on directly over point B. So they have these triangles set up. Which is 3 miles apart. So point A and point B are 3 miles apart. You can see that labeled on the diagram there. Okay. A few minutes after the plane passes over B, the angle of elevation from A to the plane is 43 degrees. The angle of elevation from the plane to point B is 67 degrees. They want to know how high the plane is at that moment. So like the height of the plane. They want to know like that little thing there, right? Like that's what they want to know. And the height of the plane is staying the same the whole time. So like the height here is the same as the height here all the way across. Okay. But we've got a couple triangles that are happening here. Actually, how many? How many triangles do we have? Technically 3. Yeah. So let's divvy these up. And let's see what we've got going on here. All right. I'm going to look at, we might not use all 3 of these, but I'm going to divvy them up, and let's start talking about this guy first. This is A and B and C up top here, where we have 3 and 43, and they give us a little a there, which we must maybe use at some point, I'm guessing. Yeah, we must use little a at some point. I know we do. Yeah, that'll work. Yep, we can do that. And then I'm just going to look at the little inside triangles. I'm not going to look at the overall big triangle that looks like this. Like, I'm not going to look at this one. Okay, we're going to just do that one, and then we're going to do the other sliver of him. So D and B and C. And we got H and we got A, and I guess we don't know this third side, but we know that that's 67 degrees. Okay, so those are the 2 that we're divvying up. Okay, now one of those is a right triangle. True? This one over here, but this one is not. So this is the one that we probably have to use the law of cosines on. So here's the law of sines on. The deal here is we could do SOHCAHTOA with him, true, to find H. Ultimately, we want to find H. We could do SOHCAHTOA as soon as we find A, true? Like sine, cosine. Okay, so 67 is my angle. H would be the opposite. A is the hypotenuse, right? So we could do sine of 67 equals H over A, but we don't know A yet, right? So like ultimately that's going to be like my final step is to solve him or solve H using that A value, right? But we've got to go over here to this guy and use the law of sines in order to find little a, right? Okay. So when we're doing the law of sines, we have to have opposites. So I could do like sine of 43 over A equals sine of something over something, right? You got it. So I need, if I'm going to use 3 as my bottom side here, I have to know this angle, right? But in order to know that angle, I have to find this angle. But he's paired with the 67. So they add up to be 180 right here, right? Mm-hmm. And that would be like what? 113. 113, yeah. Right? 113. Okay, so if that's 113, then what would this angle up top here be? 24. Perfect. Okay. So now I can use 43 and A as my one grouping, and 24 and 3 as my other grouping. So sine 24 over 3. You see how we got that? Mm-hmm. Now we got to solve for A. All right, so I'm going to cross multiply these guys, and then I'm going to divide by sine 24. Can I do that without writing it all out? Are we good with that? Do you have to do the inverse sign? No, because you're only solving for A. So cross multiply those, divide by sine 24. Let's get A. And what do you got? Make sure you're in degrees on your calculator. It should be bigger or smaller than 3? Bigger than 3, right? 43 is bigger. Okay. 5.03. Perfect. Okay, we'll use 5.03. Now, I can hop over to the right triangle that I have, and we've already set it up over here. We know that sine of 67 is H over A, but A is 5.03. So how do I get H then?
Sine 67 times.
Yep, I'm going to multiply the 5.03 over
4.63.
4.63, and that is the height. Are we in miles? Miles, I think. 3 miles? Yep, miles. So 4.363 miles in the air is how high that plane is, going constantly parallel to the ground. Yeah, that wasn't too bad. Okay, good, good. A lot of stuff going on. All right, area of a triangle. We know for area of a triangle that if I have a right triangle, like let's say I have this guy over here where this is 3 and this is 4, area of a triangle is half the base times the height, or base times height divided by 2, right? So like in this case, it would be 1/2 times 3 times 4, and that would be like 6 or something, right? Would be the area of that triangle. But the area of a triangle, when you don't have a right triangle, you can solve for him by talking about the height. It's still going to be 1/2 base times height, right? They still have 1/2 BH. But the height of the triangle is based upon the sine of this angle, right? Like opposite and hypotenuse. Okay, opposite hypotenuse, you could use that to solve for h. And so they've taken the 1/2 BH and they've rewritten it as 1/2 AB sine of C. Okay, so let's dissect that here in just a minute. 1/2 AB sine of C, that's the formula that you use for area of a non-right triangle. Okay, problem. Sometimes they don't give you angle C. Sometimes they give you angle A or angle B. But here's the deal. If C lives here and A lives here and B lives here, right? If we're talking about angle C, they want to use also in the formula little a, which is here, and little b, which is here. It doesn't matter which angle you have, as long as the two sides that you are given are right next door to the angle. Does that make sense? Okay, so over here, I don't know if this is angle A, angle B, or angle C, but I need, for the formula to work, I need to know the two sides that are adjacent or right next door to that angle. Does that make sense? Do I have those two in this triangle? Yeah, I have 8 and 13. Those are good to go. So all I do is just plop the angle in here, and I plop the two sides that are adjacent next to him, and I just solve, right? Okay, so 1/2 BC sine of A, or AB sine of C, they call it. AB sine of C. C is going to be my 130 degrees, so 130 is going to go here. And I get to choose which one is A and which one is B, technically, right? You know how I'm going to do it? I'm going to put 8 first. Why?
Because it's an easy half.
Yeah, I'm going to take half of that first number. So if you can put an even number first, half of 8 is 4, and 4 times 13 is 52. Then I just have to enter 52 sine of 130 in my calculator. Okay, I can do some of that mental stuff in my head. So 52 sine of 130 is something.
39.8.
39.8. Okay, what's the label on it? Centimeter squared. That's the area of that. Make sense? So it doesn't matter what your angle's called. If your angle's called A, it doesn't matter, just as long as you have the two sides that are right next to him. Okay, now, the next thing that we have is something called Heron's formula, and this is another way of finding area. So this is a second way of finding area if the only thing you're given is the three sides and not an angle, okay? So I have three sides of a triangle, and one of them is 7, and one of them is 9, and one of them is 12, and I could still find the area of that thing. He is not a right triangle, so I can't just do like 1/2 base times height, and here's how I do it, okay? I have to do kind of two formulas in one. This is called Heron's formula, all right? So I start with this part down here, and I have to solve for like what's called S, okay? And S is 1/2 of A plus B plus C. So I add all the sides together. 7 plus 9 plus 12, okay? To find what S is. 7 plus 9 plus 12 is 16 plus 12 is 28. And then you said half of that is 14. Perfect. So my S value is 14. Got it? Now I just take that 14 and I plop him up here. So I take the square root of S, which is 14, times 14 minus 7, times 14 minus 9, times 14 minus 12. Okay, some of that you can do in your head if you want to, right? Okay, so this is 14. 14 minus 7 is 7. 14 minus 9 is 5. 14 minus 12 is 2. I'm going to take the square root of all of that together. Make sense? So you find S and then you use that to plop into the top. 14 times 7 times 5 times 2 is, and the square root of that is something. And they don't tell me what the units are. Do you get an answer?
I got 31.3.
Yep, me too.
31.3 units squared. Yep. So when they give you all three sides and no angles, you do this first part to solve for like the value of S, and then you plop it in. So it looks like two really ugly formulas, but they really don't take that long. Okay. So they give you three sides. You use the Heron's formula. If you have an angle, you're going to use the 1/2 AB sine C. Got it? Okay, that is all the back side of the homework page that we did. So all of this is finding area, right? So like 9, 10, 11, 12, okay? Number 9, you're given an angle, right? So this is where you're going to use the 1/2 BC sine of A, right? 1/2 BC sine of A, or they call it 1/2, what did they call it? AB sine of C. Whatever. It doesn't matter what you call it, just as long as these two sides are the ones touching angle A, right? Which they should be, because angle little a should be opposite angle A, right? So that's the formula that you're going to use for that one. Number 10 is going to be a Heron's formula, because you have three sides, right? Three sides. This one is also going to be the 1/2 AB sine of C, or whatever it is. And then Heron's formula again, okay? Is that it? Yep, that's it. You have all the formulas down here if you need them. There they are,
So nice.
which is so nice. So you can just go back to those. And that's it. That's all I have.
Maybe
Yay.
look at 8 real quick.
Sure. 8?
I'm
Sure.
mad about that too.
Yeah. Okay, so this one. All right, yeah, this is interesting. Because they don't have these labeled as which one is which, right? Okay, so here's the deal. Let's say A lives here, B lives here, C lives here. I have to kind of draw this out. A is 45 degrees, okay? Little a lives here, right? Little b is the bottom side, little c is this side, right? Okay, so when they say AB is 10, AB is another way of saying which side? Little c. AB is right here, that's little c. So I'm going to rename him little c.
Okay.
Got it? And then BC is this guy right here. This is another way of saying little a. Okay, does that make sense? All right, now we go to the chart, the flow chart, and we go to the one where it says angle A is less than 90, right? Then we compare A with B times sine of A. Is that what it is?
Yeah.
Okay, but they don't give us B, but they give us C, and it doesn't really matter if it's B or C, right? So A is 8, and we have 10 times sine of 45, all right? So take 10 times sine of 45, and let's compare those guys. 10 sine 45. 7.07. So A is bigger, so we've got this thing going on here, all right? So is there no solutions or two solutions? Which one is that? Two solutions?
Okay.
Two solutions. Yep. So that was just another way of saying like what each side is, but just kind of a weird way. You had to kind of draw it out to see what that is. Yeah?
Yeah.
There you go. Okay, good?
Yep.
Anything else before I stop the video? Okay, goodbye, people.